There are different approaches to a limit. The first is through substitution. In cases when the resulting limit turns as undefined or indeterminate, try redefining using the other methods. Check how it is done here in differential calculus. Let's look for the limit of the function root of x plus 1 less the root of 2 all upon x minus 1 as x approaches positive 1. The first and the easiest approach is to use substitution. We are to substitute 1 for x, making the function as a root of 1 plus 1 less the root of 2, and this is divided by 1 less 1. The numerator turns out to be the root of 2 less another root of 2, and the denominator becomes 0, where eventually y is computed as 0 over 0, which is indeterminate. Having undefined or indeterminate does not mean that the limit doesn't exist, so let's attempt to simplify the function using a different approach. The presence of radicals is a cue to use conjugate, so multiply the conjugate of the function. With minus as the operator of the numerator, multiply the same two terms with plus. By multiplying the conjugate, the numerator then turns to be the sum and difference of two terms, which can be simplified as the difference of two squares. The numerator then turns into the square of the first term, which is the root of x plus 1, and the square of the second term, which is the root of 2. The denominator is also the product of the terms. Now simplify the numerator and get x plus 1 with negative 2, and this is then simplified further into x minus 1. At this point, the numerator cancels completely with the part of the denominator. The function then is transformed into 1 upon the root of x plus 1 plus the root of 2. This is the simplified configuration, so we then deal with the limit, where we substitute 1 for x. Y is then 1 upon the root of 1 plus 1, plus the root of 2. Simplifying this, we get 1 over 2 root of 2. This could be the final answer, although it is a math rule not to permit radicals in the denominator, so we rationalize, and that is by multiplying the radical. In this case, we only need to multiply root of 2 on both the numerator and the denominator. Y then becomes root of 2 over 2 times 2, which then gives the final y limit of root of 2 over 4.